August 24th, 1916. Somewhere in the chalky soil of northern France, 7 men crouched in a trench called Savoy. They were soaked in sweat despite the cool morning air. Before them sat their weapon, a hulking mass of steel and brass that weighed more than a man could comfortably carry, the Vickers machine gun. In a few hours they would ask this machine to do something that had never been attempted before. They would ask it to fire continuously for 12 hours. They would ask it to rain death on an enemy 2,500 yards away. They would ask it to consume nearly 100,000 rounds of ammunition without stopping, without breaking, without mercy. The gun would not disappoint them. This is the story of the Vickers machine gun, a weapon so reliable that soldiers would urinate into it to keep it firing, so deadly that it changed the nature of warfare, and so perfectly engineered that nearly 50 years after this day at the Somme, another Vickers would fire 5 million rounds over 7 days and emerge completely unscathed. But to understand why 7 men sat in a trench on August 24th, 1916, placing their faith in a machine, we must go back 32 years to a workshop in London, where an American inventor was about to change the world. In 1884, Hiram Stevens Maxim, an American inventor living in London, created the first fully automatic machine gun Wikipedia. Maxim was a prolific inventor who had already patented everything from hair-curling irons to electric lighting systems, but it was a chance conversation at the Paris Exposition in 1881 that would direct his genius toward weaponry. A fellow attendee supposedly told him that if he wanted to make a fortune, he should invent a machine to help Europeans kill each other. Maxim took the advice to heart. He founded the Maxim Gun Company in November 1884 with financing from Albert Vickers Wikipedia, son of steel entrepreneur Edward Vickers. The weapon Maxim created was revolutionary. Unlike the hand-cranked Gatling guns that preceded it, the Maxim gun was fully automatic. It used the recoil energy from each fired cartridge to eject the spent round and chamber the next one. Pull the trigger once and the gun would continue firing until you released it or ran out of ammunition. The mechanism was elegant in its simplicity and devastating in its effectiveness. The Maxim gun was water-cooled, with a jacket surrounding the barrel that held approximately 1 gallon of water. This allowed the gun to fire continuously without the barrel overheating and warping. It was belt-fed, typically using 250-round fabric belts, and it could fire up to 600 rounds per minute. At the time, this was equivalent to the firepower of 60 riflemen. The weapon was heavy, bulky, and required a crew of 4 to 6 men to operate and move it. But in terms of pure killing power, nothing else came close. The British Army was sceptical at first. When Maxim demonstrated his gun, military officials stated it needed perfecting before they would consider adopting it. One officer famously asked why anyone would need 50 bullets when one would do. They also seemed confused about whether it was a machine gun or a field gun. The Chinese, when Maxim toured his invention to potential buyers around the world, remarked that expending so many bullets was too expensive. But some military minds recognized the weapon's potential. Sir Garnet Wolseley, who had been appointed Commander-in-Chief of the British Army in 1888, placed an order for 120 rifle-caliber Maxim's Wikipedia. Wolseley had led military expeditions in Africa and had a reputation for embracing military innovation. He understood what others could not yet see. The machine gun was about to become the dominant weapon of warfare. The Maxim gun saw its first significant combat use in colonial conflicts. On October 25, 1893, 700 British South Africa Company police troops were attacked by 3,500 Matabele warriors. 5 Maxim guns killed about 500 warriors LOC. A week later, another battle saw 2,500 warriors killed out of 6,000, again primarily due to the Maxim gun. These lopsided massacres demonstrated the terrible arithmetic of the machine gun. One man with this weapon was worth hundreds without it. The Maxim gun earned a grim nickname during these colonial wars. Historian Martin Gilbert called it the weapon most associated with imperial conquest. It allowed small forces of European troops to dominate much larger indigenous armies. The machine gun gave European powers the technological edge that enabled the scramble for Africa and other colonial expansions of the late 19th century. But the true test of the Maxim gun would come when Europeans began using it against each other. During the Russo-Japanese War of 1904 to 1905, Russian use of Maxims in the defense of Port Arthur caused 6,200 dead among an attacking Japanese infantry force of over 35,000 LOC. The machine gun had proven it could slaughter trained soldiers as easily as it had tribesmen. Military planners around the world took notice. By the early 1900s, various nations had adopted versions of the Maxim gun, or developed their own machine guns based on similar principles. The Germans developed the Maschinengewehr 08, essentially a direct copy of Maxim's design. The Russians created the PM M1910. The French developed their own weapons, including the Hotchkiss machine gun. And the British, through the Vickers Company, would refine the Maxim design into something even better. After purchasing the Maxim Company outright in 1896, Vickers took the design and improved it, inverting the mechanism as well as reducing its weight by lightening and simplifying the action, and using high-strength alloys for certain components. Wikipedia. The key innovation was turning the Maxim's toggle action upside down, which allowed the body of the gun to be significantly smaller and lighter. The heavy brass water jacket of the Maxim was replaced by a lighter, corrugated, steel version. Various other changes made the Vickers much easier to strip and service than the Maxim. The British Army formally adopted the Vickers gun as its standard machine gun, under the name Gun Machine Mark Sir Vickers .303 inch on November 26, 1912, Wikipedia. The Vickers machine gun weighed between 25 and 30 pounds for the gun itself, with a 40 to 50 pound tripod. The ammunition boxes for the 250 round belts weighed 22 pounds each. In addition, the gun required about 7.5 imperial pints of water in its evaporative cooling system. With all equipment, ammunition and water, the full system weighed well over 100 pounds and required multiple men to move and operate effectively. The standard crew was 3 men. One fired the gun, one fed the ammunition belts, and others helped carry the weapon, its ammunition, spare parts, and water. But in practice, supporting a Vickers gun in combat required significantly more personnel to haul ammunition and water to keep it in action. The Vickers fired the .303 British cartridge at a muzzle velocity of approximately 2,440 feet per second. It had a practical rate of fire of 450 to 500 rounds per minute, though it could achieve 600 rounds per minute in short bursts. The effective range was 2,090 yards, though the gun could be used for indirect fire at ranges up to 4,500 yards. Unlike rifles, which fired single shots that a soldier had to carefully aim, the machine gun created a beaten zone. This was an area where bullets would fall in a predictable pattern, based on the gun's angle and traverse. A skilled machine gun crew could saturate an area with hundreds of rounds, making it almost impossible for anyone to cross that ground and survive. It took the Mark I approximately 600 rounds of continuous fire to boil the water in the jacket, evaporating at a rate of 1.5 imperial pints per 1,000 rounds. Wikipedia. The steam would reach the top of the jacket and enter a steam tube that led to a water can. This allowed the steam to be vented away from the gun, preventing a steam cloud from revealing the gun's position. It also allowed condensate to be reclaimed from the steam and poured back into the jacket to replenish the evaporated water. This was beautiful engineering. The gun was essentially self-sufficient as long as you could provide it with ammunition and water, and in the hell of the Western Front those commodities would be desperately needed. When war broke out in August 1914, the British Expeditionary Force had only 2 machine guns per infantry battalion National Army Museum. This was woefully inadequate. The German army, which had recognised the weapon's potential earlier, had fully integrated machine guns into their infantry regiments and had many more per unit. As the war settled into the brutal stalemate of trench warfare, the British quickly learned just how deadly the machine gun could be. On July 1, 1916, the first day of the Battle of the Somme, the British Army experienced the single, bloodiest day in its history. The British forces suffered over 57,000 casualties that day. National Army Museum, with 19,240 British soldiers killed and more than 38,000 wounded. History. The primary cause of this carnage was German machine guns. The British had bombarded German positions for a week before the attack, firing hundreds of thousands of artillery shells. The generals believed this bombardment would destroy the German defences and allow the infantry to walk across no man's land and occupy the enemy trenches with minimal resistance. They were catastrophically wrong. The Germans had constructed deep dugouts that were largely impervious to artillery fire. When the bombardment lifted and the British infantry began their advance, German machine gun crews emerged from their shelters and set up their weapons. What followed was systematic slaughter. The German Maxim, British Vickers, and French Hotchkiss machine guns were capable of spewing a deadly stream of bullets at a rate of up to 600 rounds per minute. Warfare History Network. Against unprotected infantry advancing in the open, this was devastating. Entire companies were virtually wiped out. Men who had trained together, who had shared jokes and cigarettes in the trenches, were cut down in swathes. Some never made it more than a few yards beyond their own trenches before machine gun fire found them. Others made it partway across no man's land before being caught in the beaten zones and killed. A few brave or lucky souls actually reached the German trenches, only to be killed in close combat or by supporting fire. The machine gun had revealed itself as the dominant weapon of modern warfare. Infantry, which had been the decisive arm for centuries, was suddenly vulnerable to a degree that previous generations of soldiers could never have imagined. Cavalry, which generals still believed would exploit breakthroughs and win decisive victories, was revealed to be completely obsolete. A man on a horse was simply a larger target for the machine guns. The British Army, reeling from the disaster of July 1st, began to adapt. In October 1915, the Machine Gun Corps was formed, grouping together the infantry's Vickers guns into companies of 10 guns, which would be attached to a brigade while the infantry were increasingly equipped with the new Lewis light machine guns' historical firearms. This centralisation allowed for more sophisticated tactics. Instead of having machine guns scattered throughout infantry battalions, they were now concentrated under specialist officers who understood how to employ them effectively. New tactics were developed and published in the official manual, The Employment of Machine Guns. One of the new tactics was barrage fire, where groups of guns fired indirectly to prevent enemy troop movements, give covering fire, or generally harass and suppress the enemy historical firearms. This was revolutionary. The machine gun was no longer just a defensive weapon that waited for the enemy to attack. It could be used like artillery, firing over the heads of friendly troops to saturate enemy positions kilometers away. The guns were angled high so their fire would arc over the battlefield, creating a beaten zone in enemy rear areas where reinforcements might be forming up or supplies might be moving. Among the new machine gun corps companies was the 100th Machine Gun Company, attached to the 33rd Division. In August 1916, this company would conduct one of the most remarkable demonstrations of sustained fire in military history. The location was Highwood, a small forest that had become one of the focal points of the Battle of the Somme. Highwood had originally been part of the German secondary trench line, but as British forces advanced in July, it became the centre of German defences. Over 3 months, the British mounted several attacks against the wood. During the Battle of Byzantine Ridge on July 14, 1916, the British briefly occupied Highwood, but the troops withdrew the next day medium. The Allies were determined to retake the forest, but the area's geography meant that Allied artillery was unable to support attacks accurately without risking friendly fire. Instead, it was decided that a concentrated machine gun barrage would support the next assault. From a position called Savoy Trench, there was a magnificent view of the German line at approximately 2,000 yards range. If machine guns could be positioned there, they could provide indirect fire support for the infantry attack, and critically, they could saturate the German rear areas to prevent reinforcements from reaching the front line. The commander of the 100th Machine Gun Company was Captain Graham Seaton Hutchison Medium. Hutchison would later rise to the rank of Lieutenant Colonel and write extensively about his experiences. It was Hutchison who would give the order that would make history. He commanded that rapid fire should be maintained continuously for 12 hours to cover the attack and consolidation. 12 hours of continuous machine gun fire. This had never been attempted before. Machine guns were typically fired in short bursts to conserve ammunition and prevent overheating. Even in defensive actions, guns would fire intermittently as targets presented themselves. The idea of firing for 12 straight hours was almost unthinkable. It would require an enormous amount of ammunition, a constant supply of water for cooling, multiple spare barrels as the originals wore out from heat, and crews that could maintain their concentration and technique for half a day under combat conditions. But Hutchison understood that if it could be done, it would be devastating. A continuous rain of bullets on the German positions would make it impossible for them to move reinforcements, set up artillery, or organise counterattacks. It would be like having artillery that never needed to pause to reposition or recalculate fire. On August 23rd and the night of the 23rd to 24th, the whole company was employed, in addition to 2 companies of infantry lent for the purpose, in carrying water and ammunition to Savoy Trench historical firearms. This was a massive logistical undertaking. Each 250-round belt of ammunition weighed 22 pounds. To fire nearly 100,000 rounds, they would need almost 400 belts, weighing nearly 9,000 pounds. That's over 4 tons of ammunition. And the water. The Vickers evaporated about 1.5 pints of water per 1,000 rounds fired. For 100,000 rounds, they would need approximately 150 pints, or about 18.75 gallons of water per gun. For 7 guns, that was over 130 gallons of water. In an era before motorised transport was common at the front lines, all of this had to be carried by hand through trenches and across terrain pockmarked by shell holes. Men hauled boxes of ammunition, jugs of water, spare barrels, gun oil, and all the other supplies needed to keep 7 Vickers guns firing for half a day. It was exhausting, dangerous work. German artillery could strike at any moment. But the preparations continued through the night. On August 24th, at 5:45 p.m, 7 of the company's Vickers guns opened up with barrage fire to prepare the way for the infantry historical firearms. The guns were set at a high angle, their bullets arcing through the evening air to fall on German positions over a mile away. The sound must have been incredible. 7 Vickers guns firing simultaneously produced a mechanical roar, a sustained thunder of metal on metal as the toggle actions cycled thousands of times per minute. At approximately 10 rounds per second per gun, they were throwing 70 bullets downrange every second. That's 4,200 rounds per minute across all 7 guns. Imagine being a German soldier in the target area. The first indication that something was wrong would be the sound, a strange whistling buzz as hundreds of bullets per minute fell from the sky. Then men would start dying. A bullet would punch through a soldier's helmet or body. Another would strike the man next to him. Within seconds, dozens of rounds would be impacting in the beaten zone. Anyone caught in the open would be killed or wounded within moments. Those who dove for cover would find that the fire continued relentlessly as the British gunners traversed their weapons back and forth across the target area. At 6:26 p.m, the battery ceased fire as it was feared their fire was falling short. Captain Seaton Hutchison, the company's commander, believed the fire was effective, and at 6:40 p.m, firing was resumed historical firearms. This pause, just 14 minutes, was the only significant break in the barrage. The guns continued firing as the infantry of the 100th Brigade attacked Highwood. The machine gun bullets arced over the battlefield, plunging into German positions as British soldiers advanced. The fire from the guns provided a curtain of steel between the attacking infantry and the German rear areas. Any attempt to bring up reinforcements or supplies would mean crossing that beaten zone and facing almost certain death. As the hours passed, the challenges mounted. Later that evening, water for the guns' cooling jackets began to grow scarce, historical firearms. The guns were consuming water faster than it could be brought forward. The crews became desperate. Sections from the Highland Light Infantry worked hard bringing up fresh supplies, but it wasn't enough. According to accounts recorded later, at least 4 petrol tins of water, besides all the water bottles of the company, and the urine tins from the neighbourhood, were emptied into the guns for cooling purposes. Vickers. Yes, urine. The men literally urinated into containers that were then poured into the water jackets to keep the guns firing. It sounds grotesque, but it was practical. Urine is mostly water, and when you're in a desperate situation where the alternative is having your guns seize up from overheating, you use what you have. This is one of the most famous and frequently repeated anecdotes about the Vickers gun, and it's based in documented fact. The gun barrels were becoming red hot from the sustained firing. The company began to systematically replace barrels to prevent them from failing. At 8 in the evening, the company began to alternately overhaul, clean, and replace the guns' barrels while keeping up the shooting at a somewhat slower overall rate medium. This required careful coordination. One gun at a time would cease fire, have its barrel quickly changed, be inspected, and resume firing, while the other 6 maintained the barrage. It was like changing tyres on a race car without stopping. Throughout this entire period, ammunition had to be continuously supplied. The 250-round belts had to be hand-filled from loose ammunition. Private Robert Shaw and Artificer H. Bartlett between them maintained a belt-filling machine in action, without stopping for a single moment, for 12 hours. Popular mechanics. Imagine that. Standing in a trench for 12 hours, doing nothing but filling ammunition belts as fast as humanly possible. Your hands would become mechanical, loading round after round after round. The sound of the guns firing would be deafening, the smell of cordite would be choking, and you couldn't stop because if the ammunition flow was interrupted, the guns would go silent, and the infantry, depending on that covering fire, could die. The gun crews themselves were exhausted beyond measure. At the end of the 12 hours, many of the NCOs and gunners were found asleep from exhaustion at their posts, popular mechanics. These men had maintained concentration and proper firing technique for half a day. They had to continually adjust aim, monitor the gun's function, change barrels, add water, clear any stoppages and coordinate with the other gun crews. All while shells could be falling around them, and enemy fire could strike at any moment. To keep morale up, a prize of 5 francs to the members of each gun team was offered and was secured by the gun team of Sergeant P. Dean with a record of just over 120,000 rounds, popular mechanics. One gun crew fired 120,000 rounds in 12 hours. That's 10,000 rounds per hour, or about 167 rounds per minute, for 12 consecutive hours. That's about 3 rounds every second for 43,200 seconds, without any significant break. Think about that. If you clapped your hands 3 times every second for 12 hours straight, you would barely be able to move your arms by the end. These men did more than that. They operated a complex mechanical system under combat conditions while exhausted, stressed, and in constant danger. The next morning at 6:10 a.m., the company finally ceased fire, having fired a total of 90,500 rounds in just over 12 hours historical firearms. Not quite the million rounds that would be reported in some accounts, but still an absolutely staggering number. To put it in perspective, that's approximately 14,200 rounds per gun over 12 hours. Each gun fired for 12 hours with only brief pauses for barrel changes. The logistics alone were remarkable. 90,500 rounds of .303 ammunition weighed approximately 4 tons. The water consumed was over 100 gallons. Multiple barrels were worn out and replaced on each gun, and yet the guns themselves had no mechanical failures. Not one. The effect on the battlefield was exactly what Hutchison had hoped for. Prisoners examined at divisional and corps headquarters reported that the effect of the machine gun barrage was annihilating, and the counterattacks which had attempted to retake the ground lost were broken up whilst being concentrated east of Flers Ridge and Highwood, popular mechanics. The continuous rain of bullets had made it impossible for German forces to organise an effective response. Any attempt to mass troops for a counterattack meant moving them through the beaten zone where they were cut down. The infantry assault itself did not succeed in capturing Highwood. The German defences were too strong, and the attacking battalions were forced to withdraw. But the machine gun barrage had held German reinforcements at bay and covered both the attack and the retreat. British casualties were certainly lower than they would have been without that protective curtain of fire. Highwood would finally fall to British forces on September 15th, after nearly 2 months of continuous fighting, but August 24th, 1916, had proven something remarkable. The Vickers machine gun was capable of sustained fire that exceeded anything previously imagined. The weapon's reliability was extraordinary. Ian V. Hogg, in Weapons and War Machines, describes how the British 100th Company of the Machine Gun Corps fired their 10 Vickers guns to deliver sustained fire for 12 hours. Using 100 barrels, they fired 1 million rounds without Breakdown's Wikipedia. The often quoted figure of 1 million rounds appears to be an exaggeration, the actual figure being closer to 100,000. But even this lower number was unprecedented. And the reliability was the key factor. Not one mechanical failure across 7 guns firing for 12 hours. This reliability was what endeared the Vickers to British soldiers. As Hogg noted, it was this absolute foolproof reliability which made soldiers love the weapon. It never broke down, it just kept on firing and came back for more. Throughout the rest of World War I, the Vickers proved its worth again and again. It served on every front where British forces fought. It was adapted for use on aircraft, armoured vehicles and ships. The basic Mark I design adopted in 1912 remained essentially unchanged throughout its service life. That's a testament to how well engineered it was. When you design something correctly from the start, you don't need to keep redesigning it. But the ultimate test of the Vickers gun's reliability wouldn't come on a battlefield. It would come in a peacetime test nearly half a century later at a place called Strensall Barracks in Yorkshire, England in 1963. By 1963, the Vickers gun was obsolete. The Vickers remained in service with the British Army until March 30th, 1968 Wikipedia, but it was being phased out in favour of more modern weapons. The British Army had stockpiles of old .303 ammunition that was no longer approved for service use. Someone had to dispose of it, and someone, perhaps with a sense of history and a desire to prove a point, decided to do it in the most spectacular way possible. A class of British Army armourers at Strensall Barracks was given a mission. They had approximately 5 million rounds of Mark 7.303 ammunition that needed to be expended. They had one newly rebuilt Vickers gun, and they were going to fire every single round through that one gun to see what would happen. 5 million rounds were fired from a single Vickers, which was kept in constant use for 7 days and 7 nights Arcipedia. British Army Sergeant T.R. Ashley was one of 9 armourers involved. He later provided a detailed account of what happened. The first day was spent gauging limits and setting the gun up. The armourers spent 2 days hand-filing components to close tolerances so the gun and tripod could be assembled without play. This kind of precision was characteristic of how seriously the British military took machine gunnery. Once the test began, it didn't stop. The teams worked in pairs, switching off every 30 minutes Arcipedia. 2 men would feed and fire the gun while a third shovelled away the spent brass cartridges. They fired in 250 round bursts, the standard belt length. The gun never stopped for more than a few minutes at a time. The worn-out barrels were changed every hour and a half, popular mechanics. Think about that. Every 90 minutes for 7 days straight someone had to change the barrel. That means they went through approximately 112 barrels during the test. Each barrel change had to be done quickly and precisely to keep the gun in action. For 7 days and 7 nights, the distinctive sound of the Vickers firing echoed across Strensall Barracks. The noise must have been incessant. Anyone trying to sleep within a mile of the range would have been kept awake by the mechanical thunder of the gun. As Sergeant Ashley later recounted, by the end of the test, the gun pit was surrounded by mountains of boxes, belts, cases, and debris. A large cleft had appeared in the stop butts where the bullets had destroyed the butts, Arcipedia. 5 million bullets impacting in roughly the same area will do that. The target berm was literally being eroded away by the sustained impact. But what about the gun itself? After 7 days of firing, they took the Vickers off its tripod and brought it back to the workshop for inspection. They carefully measured every critical dimension, checking for wear on the moving parts, inspecting the action, examining the water jacket. No measurable difference anywhere. It had eaten barrels, but mechanically the gun was unchanged Arcipedia. Let me repeat that. After firing 5 million rounds, the gun showed no measurable wear. The barrels, of course, were worn out and had to be changed regularly. That's expected. The barrel is the part that takes the most punishment from hot gases and high pressure. But the mechanism itself, the intricate system of levers and springs and toggles that made the gun function, was still within service specifications. You could have issued that gun to a unit and sent it into combat, and it would have performed perfectly. This test is one of the most remarkable demonstrations of reliability in the history of firearms. 5 million rounds is an almost inconceivable amount of ammunition. If you fired a modern assault rifle and changed the barrel whenever necessary, the gun would likely fail long before you reached 5 million rounds. Internal components would wear out, springs would lose their tension, extractors would break, feed mechanisms would fail, but the Vickers just kept working. Why was the Vickers so reliable? The answer lies in its design and construction. Vickers used high-strength alloys for certain components and simplified the action compared to the original Maxim design Wikipedia. The toggle lock mechanism was robust and had few parts that could fail. The recoil operation meant that the gun was powered by its own firing cycle. As long as you provided ammunition and kept the barrel cool, it would continue firing. The water cooling system was key. Air-cooled machine guns, which became more common later, had to be fired in short bursts to prevent the barrel from overheating. But a water-cooled gun like the Vickers could maintain sustained fire almost indefinitely as long as water was available. The water absorbed the heat from the barrel, turned to steam, and was vented away. This allowed for continuous fire that would destroy an air-cooled weapon. The engineering tolerances were also critical. British armourers took pride in their work. As Sergeant Ashley noted, they spent 2 days hand-filing parts to ensure perfect fit. This kind of precision meant that parts moved smoothly, without excess friction or stress. It meant that wear was minimised and distributed evenly. It meant that the gun would function reliably even in harsh conditions. The Vickers was also overbuilt in the best sense of the term. It was heavy, yes, but that weight came from substantial construction. The components were strong enough to handle stresses far beyond normal operating conditions. This gave the gun a safety margin that allowed it to survive abuse that would destroy lesser weapons, and the design was proven. By 1963, the Vickers had been in service for over 50 years. Millions of rounds had been fired through thousands of guns in 2 world wars and countless smaller conflicts. Every possible failure mode had been identified and addressed. The design had been refined through decades of use. What remained was a weapon that simply worked, under any conditions, every time. Compare the Vickers to its contemporaries and successors. The German MG-08, based on the original Maxim design, was reliable but heavier and more complex. The French Hotchkiss, while effective, had a different operating system and different strengths and weaknesses. Later air-cooled machine guns like the American M60 or the Belgian MAG-58 were lighter and more portable, but they couldn't match the Vickers for sustained fire. A modern general-purpose machine gun like the M240 or the FN MAG can fire a few hundred rounds before needing a barrel change. The Vickers could fire thousands before needing the same. This made it ideal for the kind of work it was doing at Highwood in 1916, sustained continuous fire over extended periods. The Vickers was a specialist weapon for a specific role, and within that role it was unmatched. The legacy of the Vickers extends far beyond its mechanical reliability. It represented a turning point in how military forces thought about firepower. Before the machine gun, the power of an army was measured primarily in how many riflemen it could field. A battalion of 1,000 men had 1,000 rifles, and therefore 1,000 sources of fire. Each rifleman could fire perhaps 15 aimed shots per minute under ideal conditions, but a single Vickers gun with a 3-man crew could fire 500 rounds per minute. That meant one gun team could put out more fire than 30 riflemen. A company of 10 Vickers guns could match the firepower of 300 riflemen, and could do so for far longer without tiring. This changed the mathematics of warfare. You no longer needed massive armies to hold a position. A few well-placed machine guns could stop an attack by a force many times larger. This was the lesson of July 1st, 1916 at the Somme, where German machine guns inflicted catastrophic casualties on attacking British forces. It was also the lesson of August 24th, when 7 British Vickers guns created a zone that German forces could not cross. The machine gun made defensive warfare dominant in World War I. Trenches, barbed wire and machine guns created a tactical situation where attacking was almost suicidal unless you had overwhelming artillery support. This led to the stalemate of the Western Front, where millions of men faced each other across no man's land for years, unable to achieve a decisive breakthrough. The solution to this defensive dominance would eventually come from new technologies: tanks to break through defensive lines, aircraft to attack enemy positions from above, and new infantry tactics that emphasized infiltration and combined arms operations. But even as warfare evolved, the machine gun remained central. World War II saw machine guns on every side, mounted on vehicles, aircraft, ships, and used by infantry. The basic concept that Hiram Maxim had pioneered in 1884 remained valid. A weapon that could fire continuously and put out enormous volumes of fire was invaluable on the modern battlefield. Today's military forces still rely heavily on machine guns. They're lighter, more portable, and more reliable than ever. But they all owe their existence to that original Maxim design and to the Vickers refinement that proved a machine gun could be built to last. The men who served the Vickers in World War I had a complex relationship with their weapon. It was heavy and required significant effort to move and maintain. It consumed enormous quantities of ammunition and water. It was a target for enemy artillery because of its distinctive sound and the devastation it could inflict. But it was also reliable. When soldiers' lives depended on their weapon functioning, the Vickers never let them down. It fired when you pulled the trigger. It could engage targets at ranges where rifles were ineffective. It could suppress enemy positions and allow friendly forces to maneuver. And as the men of the 100th Machine Gun Company proved at Highwood, it could fire for 12 hours straight if you needed it to. There's a reason soldiers loved the Vickers. In war, reliability is more valuable than any other quality. A weapon that works 90% of the time will get you killed during the 10% when it fails. A weapon that works 100% of the time, every time, under any conditions, is worth its weight in gold. The Vickers was that weapon. You could drop it in mud, and it would still fire. You could fire it until the water in the jacket boiled away, pour in more water, or even urine if necessary, and it would keep firing. You could fire it for hours, days, or in the case of the Strenzel test for a full week, and it would continue functioning. This wasn't marketing hype or theoretical capability. This was proven in combat and in controlled tests. The Vickers did what it was designed to do, and it did it better than almost any weapon before or since. The story of the Vickers is also a story about British engineering and manufacturing at its finest. The gun was a product of the Industrial Revolution, a time when British firms led the world in precision manufacturing. Companies like Vickers, Armstrong and others built everything from battleships to bicycles to the highest standards. The Vickers gun benefited from this tradition. It was manufactured to close tolerances using high-quality materials. Each gun was tested before leaving the factory. Armourers in the field maintained the weapons carefully, understanding that proper maintenance meant reliable function. This attention to detail and quality is part of why the Vickers lasted so long in service. The British Army continued using the Vickers until 1968 Wikipedia, more than 50 years after its adoption. Some nations continued using Vickers guns even longer. That's an extraordinary service life for any weapon. Most military firearms are replaced after a decade or two, as newer designs become available. But the Vickers was so well designed and so reliable that there was no pressing need to replace it. It did its job, and it did it well, for generation after generation of soldiers. There's also something to be said about the human element in the Vickers story. At Highwood, the success of the 12-hour barrage depended not just on the gun's mechanical reliability, but on the determination and skill of the men who operated it. They had to maintain concentration and discipline for 12 straight hours. They had to coordinate their actions, change barrels without interrupting fire for long, keep ammunition flowing, and solve problems as they arose. When water ran short, they improvised. When barrels wore out, they changed them. When exhaustion threatened to overwhelm them, they kept going. This is the nature of warfare. Technology and tactics matter, but ultimately it's people who fight wars. The Vickers gun was an outstanding piece of engineering, but it was only effective because skilled, determined soldiers operated it. Captain Graham Seaton Hutchison's decision to order the 12-hour barrage was bold, but it could only succeed because his men were capable of executing it. Similarly, at Strenzel in 1963, the 5 million round test required not just a reliable gun, but a team of dedicated armourers who worked in shifts for 7 days to keep it firing. They had to maintain discipline and attention to detail throughout. Any mistake, any moment of carelessness, could have damaged the gun or endangered the test. But they maintained their professionalism, and the test succeeded. The psychological impact of machine gun fire shouldn't be underestimated either. Modern soldiers who have experienced being under machine gun fire describe it as one of the most terrifying experiences in combat. The sound of bullets passing overhead, the knowledge that you're in a zone where death is being distributed randomly, the helplessness of not being able to effectively return fire against a weapon with such overwhelming range and firepower. All of this creates intense stress. In World War I, soldiers described the sound of machine gun fire as like cloth tearing, a rapid ripping sound as hundreds of bullets per minute passed through the air. At night, you could see the tracer rounds arcing across no man's land, every fifth round glowing red as it flew. Soldiers learned to fear that sound and that sight. German troops called machine guns Teufelsspritze, the devil's watering can, or Knochenmühle, the bone grinder. These names reflected the terror the weapon inspired. When the British barrage began at Highwood on August 24, 1916, German soldiers hearing that sustained fire would have known they were facing something extraordinary. The normal rhythm of machine gun fire is burst, pause, burst, pause. But this was continuous. For 12 hours, bullets rained down on their positions. Any attempt to move, to bring up supplies or reinforcements, meant crossing that beaten zone. The psychological pressure must have been immense. There's a broader historical significance to the Vickers story as well. The machine gun, more than almost any other weapon, changed the nature of warfare in the 20th century. It made defensive positions far stronger than offensive operations, leading to the trench warfare of World War I. It forced military thinkers to develop new tactics and technologies to overcome defensive firepower. It changed how armies were organised, with specialist machine gun units becoming standard. It influenced the development of armoured vehicles, which were created in part to provide protection against machine gun fire while crossing open ground. It changed infantry tactics, with soldiers learning to move in small groups using cover and concealment rather than advancing in dense formations. The machine gun's influence extended to naval and air warfare as well. Aircraft machine guns allowed fighters to shoot down other aircraft and strafe ground targets. Naval vessels mounted machine guns for anti-aircraft defence and for engaging small boats. The basic principle, a weapon that could fire continuously and deliver high volumes of accurate fire, proved valuable in every domain of warfare. Hiram Maxim's invention in 1884 was truly revolutionary, and the Vickers refinement of that design created one of the most successful weapons in history. Today, original Vickers guns are collector's items and museum pieces. They're occasionally seen at historical demonstrations where they're fired to show modern audiences what they sounded like. The distinctive sound is still impressive, a mechanical hammering that seems impossibly fast for something human-operated. The guns that survive are testaments to their quality of construction. Many are still functional after more than a century. With proper maintenance and care, a Vickers gun could probably still be fired today, and would function as reliably as it did in 1916 or 1963. That's an achievement few weapons can match. The story of August 24th, 1916, deserves to be remembered not just as a footnote in the history of the Battle of the Somme, but as a demonstration of what human ingenuity and determination can achieve. 7 gun crews, working through exhaustion and privation, fired nearly 100,000 rounds in 12 hours without a single mechanical failure. They consumed ammunition by the ton, water by the hundreds of gallons, and replaced barrels as they wore out. They improvised solutions when supplies ran short. They maintained discipline and precision for half a day under combat conditions, and they proved that the Vickers machine gun was the most reliable automatic weapon ever created. When those 7 guns finally fell silent at 6:10 a.m. on August 25, 1916, they had written a page in military history that has never been matched. No other weapon has demonstrated such sustained firepower under combat conditions. The crews had fired until they literally fell asleep at their posts from exhaustion. The guns themselves were ready to continue if called upon. In the decades since, military technology has advanced tremendously. Modern machine guns are lighter, more portable, and easier to maintain than the Vickers. They use better ammunition, more efficient operating systems, and advanced materials, but none of them can match the sheer, stubborn, absolute reliability of the Vickers. When you needed it to fire, it fired. When you needed it to fire for 12 hours, it fired for 12 hours. When you needed it to fire for 7 days, it fired for 7 days. The Vickers machine gun was a weapon that never quit, never failed, never let down the soldiers who depended on it, and that, more than any technical specification or battlefield statistic, is why it deserves to be remembered. On August 24, 1916, 7 Vickers machine guns fired until they should have failed, until logic said they must fail, until common sense insisted they would fail. But they didn't fail. They kept firing, kept working, kept doing exactly what they were designed to do, and in doing so they created a legend that would last longer than the British Empire that built them, longer than the war they helped to win, longer than any of the men who served them. The thunder of those guns has long since faded. The battlefields where they were fired are now peaceful farmland. The men who served them are gone. But the story remains, a testament to engineering excellence, to human determination, and to a weapon that simply refused to quit. That's the legacy of the Vickers machine gun, and that's why, more than a century later, we still remember the day the guns fired until the barrels melted, except they didn't even do that. They just kept firing,